Hello, super students. Today we are going to learn proportions. Let's go ahead and get started. I know you have been you've been missing the you will be able to, so it's back. Here we go. You will be able to solve proportions using 3 strategies. We're first going to talk about a unit rate strategy, then we're going to learn a scale factor strategy, and then also a table strategy. Before we get started with our strategies, we want to first take down the definition of what is a proportion. A proportion is an equation that states that 2 ratios are equal. Okay, we're first going to get started with the unit rate approach, and we're going to work through this same problem 3 different times using each of our strategies. So the problem reads, in Erin's career on the basketball team, she made 8 out of every 12 free throws. Last season, she attempted 60 free throws. How many did she make? Here's what we first need to do. We need to set up our first ratio and understand what are we comparing. We are comparing shots made, so I'm going to write it off to the side here. Shots made to shots attempted. And now we're going to attach our numbers to them. So she made 8 shots out of every 12 that she attempted. And then if she attempted last season 60 shots, then how many did she make? In that whole setup, I talked my way through it and I wrote my equation of 2 ratios set equal to each other. And now what we're going to have to do is this unit rate approach is being able to look within our ratio of a shots made to shots attempted. So our 8 shots made to every 12 that we tried. And we're going to see if we can go by a unit rate or reduce that ratio. So I think back to my fractions. I know that 8 and 12 are both divisible by 4. And so I'm going to reduce this ratio into 2/3. So this describes that she made 2/3 of her shots. Then I'm going to drop down the equal sign and also the rest of the equation. So I have our unknown, our question mark, out of the total 60. And then what we're going to do is look across. I know that 3 times 20 gives us 60. So then we should multiply the numerator by 20 and we end up getting 40. So that's how many shots she made if she attempted 60 last season. And we're going to add some labels to this. So this ends up she made 40 shots made. And then box our answer out. So that is what the question mark stands for. Let's try the next approach. Again, we're going to work with the same problem, and we're just going to solve it a different way. Our first idea, again, is to set it up the same way. So we're looking at shots made compared to the shots attempted. And in this case, when we set it up, we're still going to compare the shots made were 8 out of 12 attempted. And set that equal to, if she attempted 60 shots, then how many did she make? And instead of reducing 8/12 to try to find a unit rate with it, I can actually find the multiplication relationship right across right away by thinking about what factor times 12 gives us 60. And I know that 12 times 5 gives us 60. So that means 8 times 5 gives us our answer here of 40 again, so that it would be 40 shots made if she attempted 60 shots. That way it's just similar again to the unit rate, but we were able to find our factor right away by knowing the relationship that 12 times 5 gives us 60. Okay, our third strategy that we're going to use is a table strategy. And the table strategy is a mix of unit rate and also noticing how our factor changes as we go. The setup that we use is we make a T-chart and we have our shots made in one column and our shots attempted in the other column. And what we're looking for is patterns. So we know we have to get our way down to 60. And so I'm going to just start filling out my table of saying, okay, if I made 8 shots, then the next amount of shots that I would make would be 16. So I'm just adding on 8 to that, which means on the other side or the right side, we would add on another 12. So we'd get 24. And then from there, if I made another 8 shots, that would give me a total of 24 shots made, which would make my shots attempted be out of 36. And then from there, it would be another add-on to 24 would get us to 32. So if I made 32 shots, then that would mean I attempted 48. And then after that, 48 plus 12 gets us to 60. 32, I would add on another 8, gets us to 40. So here we are with our answer again of seeing that I would have attempted, if I attempted 60 shots, then 40 of them I would make, keeping all of those ratios equivalent to each other. Okay, we are going to look at another example for ourselves and just practice the 3 strategies one more time. So here's our other example. It says 2 baseballs cost $5. How much will seven baseballs cost? So from our unit rate approach, remember we're trying to figure out, in this case, how much would 1 baseball cost for us? Before I start doing the math, I just want to set up, again, we're going to go price over size. So now that I write my numbers with it, I know $5 for 2 baseballs. And I'm setting that equal to how much would 7 baseballs cost. And now I'm going to look within the ratio and I'm going to figure out how much does it cost for 1 baseball. So the math set is to divide 5 by 2 and see that each baseball will cost $2.50. So $2.50 for 1 baseball. Using that information, now what we can do is multiply, what do you think? 1 going across times 7 gets us to 7 baseballs. So then we would multiply 250 by 7 and we get that 7 baseballs would cost us $17.50. Again, here we go with trying the same problem, but using a different approach. We're going to use the scale factor approach. So we'll set it up the same way with price over size. So we're going to say that it costs us $5 for 2 baseballs. And again, we want to know how much will 7 baseballs cost. When I think about this unit rate approach, what I'm thinking about is if baseballs came in packs of 2, how many packs of 2 would we need? Thinking about if you could break a pack apart. So I know that factor in my head, I would need 3.5 packs of baseballs because I know 4 times 2 would give us 8 baseballs. So if I could take just 1 baseball out of the pack, then that would be times 3.5. And then I multiply the numerator by the same scale factor number. So we were doing 5 times 3.5, which gives us the same total of $17.50. So knowing that we get the same amount, the same price, by just using a different approach. Okay, here we are again with our third approach of using the table strategy. Notice we already set it up, baseballs in one column and money in the other. And now we're just going to continue our table. So again, if after buying 2 baseballs, if we bought 4 baseballs, that would cost us $10. If we bought 6 baseballs, that would cost us $15. If we now bought 8 baseballs, that would cost us $20. Notice I left a space between 6 and 8, because we're trying to figure out how much will 7 baseballs cost. So in between the number 6 and 8 is the number 7. And then in between 15 and 20, I know that those are increasing by a +5. So I have to do what's half of 5, which is $2.50. So then I just add on $2.50 to 15 and we get $17.50. So from our table strategy, we can find numbers in between. And in this case, we found out that again, 7 baseballs cost $17.50. A different approach, still getting the same answer. Okay, now we're ready to apply our skills that we learned. And it's our choice to choose any method that we want. One of the ones that Miss Martson and I are going to have you choose is probably the unit rate or the scale factor method for the majority of our problems. And it's all about the setup. We want to be able to set up our proportion first. So our first question says, Julie can do 20 math questions in 5 minutes. How many can she do in 1 minute? This question is really asking us to find the unit rate. So we're first going to set this up and label, what are we comparing? We're comparing how many math questions we can do in a certain amount of time. So I have 20 math questions, and I'm just going to use Q for questions, in 5 minutes. So how long or how many questions would I solve in 1 minute if I'm doing them at a rate of 20 questions per 5 minutes? To get us to our unit rate, we're going to divide both the numerator and denominator by 5 because that's how we get to 1. So 20 divided by 5 gives us 4. So we can solve 4 math questions per each minute. Our next question states, 4 packs of candies cost $5. How much would 2 packs cost? So we're going to set it up. Remember, price over size. So we have $5 over 4 packs. And we're setting that equal to how much would 2 packs cost. And I know when you look left to right, our brain kind of gets trained to go left to right. But if we wanted to, we could go the other direction and multiply 2 times 2 and get back to 4. Oh, so you could think, what times 2 gets you to 5? Or you can still be going that division route of saying, okay, we know 4 divided by 2 gets us to 2, so then we have to do 5 divided by 2. And again, half of 5 is $2.50. So we know it's going to cost us $2.50 for 2 packs of candy. The last example states, the city bus goes 18 miles in 30 minutes. So we're first going to set up that ratio or that rate where it's traveling 18 miles in 30 minutes. And then we want to know how far does it go in 10 minutes. So looking back at our ratio, we put miles over minutes. So that means that I have to put minutes in the denominator. And then I'm going to look across my problem here and I see I'm at 30. How do I get to 10? That would be dividing by 3. So we're going to do 18 divided by 3 and we get 6 miles. Notice that we stayed consistent with labeling everything. We showed all of our work. We're showing the math of either multiplying or dividing when going across the equal sign. So really with all of these, I solved them all with the scale factor approach, except sort of this first one, it wanted us to find the unit rate. And so that came back out for us, which you'll see. All right, go ahead, finish up your note sheet, and we'll see you tomorrow.